you're welcome to Mathematics Tour. I made a solution to the IGCSE Mathematics Paper 4, Component 4.2, towards the end of July, as that's the component written in my zone. I saw the comment of one of my subscribers 2 days ago, that is 7th September 2023, that asked me to make a video on the component 4.3. Then I decided to make a video on all the components. Should you want me to make a video for you, kindly leave a comment in the comment section or send a direct message to my inbox. My email address is available on my channel. As usual, I will solve the whole 12 questions at once. If you are seeing this channel for the first time, please kindly subscribe to my channel by clicking the subscribe button and hit the notification bell to receive notification anytime I upload a new video. So what are you waiting for? It's time to join the wonderful subscribers. Let's jump into the first question. Question 1. Thomas sells a computer, a bike, and a phone. The amounts he receives are in the ratio computer to bike to phone in the ratio 14 to 17 to 9. Calculate the amount he receives for the phone as a percentage of the total. So we need to represent or denote computer by a letter C, bike by a letter B, and phone by P. So we'll have C ratio B ratio P. Then we have 14 here, 17 and 9. So what we need to do is to find the amount he receives for each of these items by multiplying the ratio by a constant number. So in this case, let the constant be x. You multiply this by x. You also multiply this by x. You multiply this by x. So we'll have 14x, 17x, and 9x. Of course, the total amount he receives will be 14x, add 17x, add 9x, and this will add up to 40x. Now, since we know the total amount he receives for the 3 items, and we want to write the amount he receives for the phone as a percentage of the total, so that will be 9x, that is the amount he receives for the phone, out of 40x multiplied by 100%. So x cancel x, and if you divide 9 by 40, you'll get 0.225, and when you multiply it by 100%, that will give you 22.5%. So that means the amount he receives for the phone as a percentage of the total is 22.5%. Then the second part of it, the total amount he receives is $560. So that means the 40x, which is the total amount he receives, is equal to $560. So if you divide both sides by 40, then you have the value of x to be 560 divided by 40. If you take your calculator and carry out this operation, then you should get the value of x to be 14. So from the ratio here, we know that he receives 17x for the bike. So we need to substitute the value of x, which is 14. So this will be 17 into 14. So if you multiply this, you will get $238. So that will be the amount he receives for the bike. Let's go to the Roman figure 3. Thomas originally bought the bike for $195. he wanted to make a profit of at least 25% when he sold it. He wanted to make a profit of at least 25%, so you need to underline this, when he sold it. Does Thomas make a profit of at least 25%? You must show all your working to support your decision. At 100%, that is the cost price of the bike, that would be $195. For Thomas to sell the bike for $238, that implies that he made a profit. So we should find the percentage profit. So to do that, that means this 100% should increase, but by what? We need to find out that. So that means we're going to write 100 plus some x percentage, which we don't know yet. Okay, so that will give us the price of what? 238. So the x is the percentage gain we want to get here. So if we cross multiply, so we are going to have 100 plus x, then multiplied by 195, then equals to 238 multiplied by 100%. So if you divide both sides by 195, that means we'll be left with 100 plus x to be equals to 238 multiplied by 100, then divided by 195. So if you do this, you have 100 plus x to be equals to 122%. So if you collect like times, so x will be equals to 122, subtract 100, then the value of x will be 22. So that means the percentage gain is 22%. So of course, we can draw a conclusion that Thomas does not make a profit of at least 25%. So the answer is no with the given reason. Then let's go to the B part of the question. Euler invests $725 for 6 years in an account paying simple interest at a rate of 1.3% per year. Calculate the total interest earned at the end of 6 years. So you need to be very careful. This question is a simple interest question. Students are fond of making a mistake by making use of the formula for compound interest. Please always take note of this when you are solving questions involving money or finance. Okay, so here we need to calculate the interest first, and we know that the principal is giving us $725, and then the rate of the interest is 1.3%, which is the same thing as 0.013 in decimal number, and the time t is equals to 60x. So we can make use of this formula. I, that's the interest, equals to the principal times the rate times the time. So if you do this, let's substitute, or let's key in the values of the parameters. We have 725 multiplied by 0.013, then multiplied by 6. So if you input this in your calculator, so the value of your interest should be 56.55. So that should be the simple interest at the end of the 6 years. So $56.55. Now let's go to the next question. In a sale, all prices are reduced by 24%. Victor pays $36.86 for a pair of shoes in the sale. Calculate the original price of the shoes. So the original price of the shoe will always be at 100%. That will be the original price. So we denote that by X. So for the reduction of 20%, that means the 38, that means the $36.86 was sold at 76%. So that means at 76%, we have $36.86. So if we cross multiply, we have 76 times X to be equals to 36.86 multiplied by 100. If we divide both sides by 76, so we have X left here, and you can easily take your calculator and do this. So you don't need to waste your time, as this will give you $48.50, or simply $48.5. So let's go to question number 2. Anna records the number of text messages she receives for 14 days. Complete the stem and leaf diagram. So you have the numbers in 2 rows. So we just have to key in the values accordingly. So that is from the lowest to the highest. So we have 3 here, that is for 13. We have 5, 7, and 8. Then for 20, we have 21. We have 21 again. You have 22. You have 27, 28, and 29. For 13, we have 31, 31, 31, and 38. So what is the key? So you can say 1, then this bar 3. Okay, you can say 1/3 represents 13, or you can take 1/5 represent 15, or 1/7 represent 17. So you can take any one as your key. Okay, so let's go to the Roman figure 2. Find the median. Since we have 14 numbers here, so if you count from the front and from the back, we have 1, 2, 3, 4. Then from the back, we have 1, 2, 3, 4. So again, 1, 2, 1, 2. So that means it's between 22 and 27. So you need to be very careful. Don't take this to be 2 and 7, okay? But 22 and 27, as we have 2/2 against 2/7. And from the key, this will be 22 and this will be 27. So the median is in between 22 and 27. So what do? We need to find the average of 22 and 27, and that will be 22 add 27, everything over 2, and that will give you 24.5. So the median is 24.5. Then we need to find the mode, that's the highest occurrence. So if you check here, you'll see that the highest occurrence is what? 31, as it appears 3 times. So the mode is 31. We need to find the range. The range is the highest number minus the lowest number. If you scroll up, the lowest number there is 13 and the highest is 38. So the range will be 38 subtract 13, and that will be 25. Okay, so that will be the range. The part B of that question is, in a shop there are 4 red and 8 gray phones. Anna and Pete each pick one of these phones at random. Work out the probability that they both pick a gray phone. So that means we are going to have gray and gray. The total is equals to 4 add 8, and that will be 12. So for the first selection, that will be 8 out of 12. and the number of gray phones would have reduced to 7, and that will affect the total. The total will now be 11. So the second selection will be 7 out of 11. So if you do this, you have 8 by 7, that will be 56, out of 12 by 11, that will be 132. So you can reduce this to the lowest form by dividing the numerator and the denominator by 4, and that will give you 14 out of 33. So that will be the probability that they both pick a gray phone. So we need to go to the next question. That will be question 3. The square drawing shows two sides, AB and BC, of a field. The scale is 5 centimeters, represent 200 meters. Measure angle ABC. So to do this, you need to pick your protractor, then the center of the protractor at point B. Then you ensure that the 0 degree is on this line, and you take your reading. So using the inner reading, we have 0 to 110, then we have additional 8, so that will be 118 degrees. That will be the angle, the value of angle ABC. Then the next thing we need to do is the second part of the question. X is a point on BC. BX is 332 meters. Mark the point X on the diagram. So for you to do this, you have to convert it to centimeter using the given scale, that is centimeter to meters, and the scale is 5 centimeters, represent 200 meters. So what will be the equivalent of 332 meters? So you can always do this. What was done to 200 to get 332? You can get that by dividing 332 by 200, and that will give you 1.66. That implies that 200 was multiplied by 1.66 to get 332. Then we need to do the same thing to this side to get the equivalent in centimeters. So that will be multiplied by 1.66. So if you multiply 5 by 1.66, you get 8.3. So that means the 332 meters in centimeters, according to the given scale, will be 8.3 centimeters. So we need to pick up a ruler. Then starting from point B, you place the ruler there. So you can place it very well like this, and you measure out 8.3 centimeters. So the 8.3 centimeters will be somewhere around here. So you put it there. So you take off your ruler. So it is here. Okay. So that will be the point X, and the BX is 8.3 centimeters according to the scale given. So the Roman figure 3 part of the question, find the scale in the form 1:n. So we already know that the given scale is 5 centimeters to 200 meters. So the first thing we need to do is to ensure that they are in the same unit. So I will leave the 2 in centimeters. So we need to convert 200 meters to centimeters. So using King Henry died by drinking chocolate milk, where the B stands for, at B you have meters, liters, and grams. So in this case we are using meters. So centimeter is here. So that means we need to move from meters to centimeters. So it implies that we have to move from the base B to see 2 times 1 and 2. So that means the 200 meters will now be the addition of 2 zeros, as we have, okay, let me show you here. You have 200.0, that's the 200 meters, and we need to move towards this direction to the right hand side 2 times. So we shift the decimal point to the front twice, 1 and 2. So let's fill the empty space with 0. That means 200 meters will be 20,000 centimeters. Okay, so that means we have 5 centimeters to 20,000 centimeters. So you must ensure they are in the same unit. Then we want to make 5 centimeters to be 1. Okay, so what do we need to do? We need to multiply it by 1 out of 5. Then we'll have 1 here. So we need to do the same thing to this side. We also multiply 20,000 by 1 out of 5, and that gives 4,000. So we have it in the form of 1:n now, which is 1:4,000. So let's go to the B part of the question. A bronze statue is 4.5 meters high and has a mass of 195,200 kilograms. The density of the bronze is 8,000 kilograms per meter cube. The volume of a mathematically similar model of the statue is 0.385 meter cube. Then calculate the height of the model. So given that the density is equals to mass over volume, what you need to do is to find the ratio of the corresponding parameters, as we have similar shapes. But the first thing we need to do, let's write out the given parameters. So the bronze statue, okay, is 4.5 meter. So that is the height, okay. So I will denote it by what? HBS. That is the height of the bronze statue, and it is 4.5 meters. Then the mass, that is M, the mass of the bronze statue. So I will denote it with MBS. That's the mass of the bronze statue, and it is given as 195,200 kilograms. And as well, we have the density of the bronze. So we have the density of bronze. So D for density and then B for the bronze. So to be equals to 8,000 kilogram per meter cube. Then volume of the model will be denoted by VMD. That is the volume of the model, and it is given as 0.385 meter cube. And we need to find the height of the model. It will be denoted by this. So we need to find this. So all we need to do is to take the ratio of the corresponding parameters. Firstly, let's find the volume of the bronze statue by using the formula density. Density is equals to mass out of volume. Okay, so we can make the volume the subject of the formula, and that will be volume will be equals to mass out of density. If you key in the values, we're going to have 195,200 out of 8,000, and that will give us 24.4 meter cube. So that is the volume of the bronze statue. So I will denote it with VBS. That's the volume of the bronze statue. Then let's scroll down a little bit. So we can now make use of the corresponding ratio. We know that the volume of the bronze statue over the volume of the model is equals to cube of the height of the bronze statue in this order over the cube of the height of the model. Okay, so you have to take it like this. Okay, so now we can easily key in the values here, and that will give us the height of the model. So let's key in the values. We have 24.4 out of 0.385 to be equals to 4.5 cube out of height of the model cube. So we need to solve this. If you cross multiply, that will give you 24.4 times h cube, that is the height of the model, to be equals to 4.5 cube multiplied by 0.385. Then if you divide both sides by 24.4, that will eliminate this here. Then you have 24.4 here. So finally we have the height of the model cube, okay, so to be equals to 4.5 cube times 0.385, everything divided by 24.4. So this will give you 1.4378, and we need to take cube roots of both sides. So if you take cube roots of both sides, so you'll be left with the height of the model here to be equals to 1.12868, and these two three significant figures, it will be 1.13. So let's go to the next question. That will be question 4. A, B, and C are three towns, and the bearing of C from A is 114 degrees. B is due south of A, and AC is equals to BC as indicated in the diagram. Calculate the bearing of B from C. So what we need to know is that, okay, firstly, let's trace a line here to denote the north pole at the point C. So if you do this, then that means we have another north pole here. Then we already know that the angle here will be 180 degrees, subtract 114 degrees, so that will be 66 degrees. And we know that this angle here, this 66 degrees, and this angle here will be what? Will be alternate angles. So if you put 66 here, so you can put 66 degrees here if you want. And also, if you consider this place will be 66 degrees as well, because at point A and point B, we have the base angles of this isosceles triangle. So that will be 66. Also, if you look at the angle at point B, that is this angle here, that is 66 degrees, and the angle here will also be 66 degrees because they are alternate angles. Okay, if you trace the Z like this and like this, okay, so now we can get the bearing of B from C. It will be from here up to this line here. We already know that from here down to this point here is 180 degrees, and we already know that from here to here is what? 66 degrees. So if you scroll down a little bit, so the bearing of B from C will be 180 degrees add 66 degrees. Okay, so that will be 246 degrees. Okay, so you can show your working by writing some things here like angle, by finding angle, by showing how you got 66 for angle A here, that is BAC. Okay, so that is, you can write something like BAC, okay, is equals to 180 degrees subtract 114 degrees, and that will be 66 degrees. Also, we can also say that ABC is equals to 66 degrees. Okay, the reason will be base angles of an isosceles triangle, and also you can say the angle here, anything, you can put a letter here, probably let's say letter D. Okay, then you can say that BCD is same thing as what ABC, alternate angles. Okay, so to just show how you got each of these angles before you add 66 degrees to 180 degrees. So that's the answer there. So let's go to the B parts. P, Q, R, and S lie on a circle. MPN is a tangent to the circle at point P. Angle MPS is equal to 58 degrees. Angle PSR is equal to 74 degrees. And angle QPN is equal to 27 degrees. Find angle PRS. So that is angle PRS. So let me mark it. So we are finding this angle here. That is the marked angle. If the angle between the tangent to the circle and this chord is 58, then angle PRS will surely be alternate to this. Okay, so to be an angle in an alternate segment. Okay, so angle PRS is 58 degrees. Let's scroll down a little bit. Roman figure 2, find angle PQR, angle PQR, so it should be this angle. So if you look carefully, you'll see that we have a cyclic quadrilateral. So, and we know that opposite angles of a cyclic quadrilateral are supplementary. That is, they add up to 180 degrees. So we can say that 74 degrees add angle PQR here. Okay, so add up to 180 degrees. So you can easily get the value of PQR by subtracting 74 from 180 degrees, and that will give you 106 degrees. And then the Roman figure 3, you have to find angle RPQ, angle RPQ, that is this angle here. Okay, if you like, you can key in the values of the angles you found earlier. We found PRS, so this place is 58. At times, it ups in your solution, okay, and then this place is 106. So to find angle RPQ, let's mark it in the diagram. So this is angle RPQ from here to here, okay? But if you continue that angle, that is from here down to the tangent, okay? So it will be, the whole of this angle will be equal to 74, because they are angles in alternate segments. Okay, so we already know that from here, let me use another color. So we already know that from here to here is 27 degrees. Then we need to find the remaining red part of that angle. Okay, and that will be angle RPQ. So to do that, you can denote this by X, and you can easily say X plus 27 degrees. So is equals to 74. So because the whole of this angle, that is angle RPN, the whole of that angle is equal to angle angle RSP, because they are angles in alternate segments. So from here you can easily get the value of x, which should be 74 subtract 27. So you have x to be equals to 47 degrees, and that will be the value of angle RPQ. So that means RPQ will be equals to 47 degrees. A, B, and C lie on a circle, center O with diameter AC. TAM and TBN are tangents to the circle, and angle ATO is equals to 34 degrees. Using values and geometrical reasons, complete this statement to show that CB is parallel to OT. So in triangles AOT and BOT, OT is common, yes. As you can see, AOT and BOT. So OT is common to the two triangles. Then angles OAT is equals to angle OBT equals to 90 degrees, because angles between a radius and a tangent is always 90 degrees. So angle OAT is between the radius and the tangent. Also, angle OBT is between the radius and the tangent. So according to the theorem, angle between a radius and a tangent is always 90 degrees. Or you can simply say radius perpendicular to a tangent. So that could be the reason. Okay, so I can say I can write radius perpendicular to a tangent, or you can say angle between a radius and a tangent. Okay, so that is the first reason. Okay, you can write this here: radius perpendicular to a tangent. Then if you scroll down a little bit, AT is equals to BT. Let's see, AT, this is AT, and this is BT. Okay, so there are, if you look at the two the two lines, AT and BT, they are both tangents, okay, drawn from an external point to a circle. So according to a theorem, it has been proven that two tangents drawn externally from a point, okay, two tangents drawn to a circle from an external point are equal. So I will say AT is equals to BT because they are tangents drawn to a circle, from an external point, So that will be the reason. Then the next one is triangle AOT is a congruent to triangle BOT because of congruence criterion. So here, if you look at the two triangles here, so you know that we have SSS, RHS, SAS, okay, and AAS, okay. So this ID criteria we use to identify similar or these are the criteria we use to identify congruent triangles. So if you look at this now, triangle AOT is congruent to triangle BOT. So let's go to the diagram. AOT, AOT, and BOT. So if you look at AOT, let's see AOT. Okay, so this is AOT here in this diagram, and then BOT, this is in Y. Okay, so if you look at the two triangles, they both have a right angle, so that will be R here. Okay, and you have the hypotenuse common to the two, that is H. Okay, and they have equal sides, so the equal sides will be BT and AT, that is the tangents. Okay, so that will be, this will be the criterion RHS. So if you scroll down a little bit, the criterion is R, the right angle, the hypotenuse, and the equal sides. Okay, so angle AOT is equals to angle BOT. So let's mark it, angle AOT, AOT, this angle here is equals to angle BOT. Okay, and it is equals to 56 degrees. So you have 56 degrees here, you have 56 degrees here. So because angles in a triangle add up to 180 degrees, okay, so of course, so this is already 90 degrees, you know, so everything should be that. So, and you already know that this one too will also be 90 degrees, of course, and this place is also 34 degrees, so you are aware of that. Now let's see the question that follows. So angle BOC will be equals to what? Because, okay, we want to find angle BOC. Angle BOC, it will be this angle here. So to find angle BOC, we know that this angle OCB and angle OBC, that is the base angles of this isosceles triangle, are equal. So we can easily find angle BOC by what? By subtracting these 56 and 56 again from 180 degrees, because they are angles on a straight line. That is, angle BOC will be 180 degrees, subtract 56, subtract 56. Okay, and if you do that, that will give us 68 degrees. Okay, and the reason will be angles on a straight line add up to 180 degrees. That will be the reason. So I will say angle BOC is equals to 68 degrees because angles on a straight line add up to 180 degrees. That will be the reason. And the other one will be angle OBC. Let's go to the diagram. Angle OBC. Okay, so this one, it is obvious, since we have angle BOC to be 68, okay, then we can easily get the base angles of this triangle OBC by subtracting 68 from 180, that is 180, subtract 68 and divide it by 2 to get 56 degrees. So this will be equals to 56 degrees. That will be the value of 56 degrees. So that will be the value of each of the base angles of the isosceles triangle. So now we can go to this and say OBC will be equals to 56 degrees because of base angles of an isosceles triangle. So to be because of base angles of an isosceles triangle of an isosceles triangle. So that will be the reason. Okay, and I think the last one, CB is parallel to OT. Okay, let's look at it. CB, where is CB? So this is CB here. Okay, parallel to OT. Why? Because angle CBO, look at this, angle CBO and angle TOB are equal. Okay, angle CBO and angle TOB are equal. So they are alternate angles. Okay, that is this angle here, the angle CBO, and then the angle TOB, this angle here. Okay, sure, they will be 56, 56. Okay, so they are alternate angles. So for that reason, they are parallel. Because if they're not parallel, you will never see alternate angles. Alternate angles exist in what? In parallel, when you have parallel lines. Okay, so I would say that CB is parallel to OT because angle CBO, okay, is equals to angle TOB. Okay, and the reason being is that they are alternate angles, or you can simply say because CBO and TOB are alternate angles. So that is how to prove that CB and OT are parallel to each other. Okay, so let's go to the next question. That will be question 5. ABC is a scaling triangle on horizontal ground. AYX is a straight vertical post held in place by two straight wires XB and YC. AC is equals to 4.8 meters, as you can see here. BC is equals to 5.6 meters, and angle ACB is equals to 20.4 degrees. So we want to calculate AB. So if you like, you can sketch it out like this to see what you want to calculate. So I have this triangle here. This is point B, point A, and point C respectively. So I can label this as side A, this will be side B, and this will be side C. So the value so this will be side A, this will be side C, and this will be side B. So side B is equals to 4.8 meters. Then side A is equals to 5.6 meters as indicated in the diagram. And we want to find length AB, which is side C, according to our diagram here. So if you scroll down a little bit, so we can write out the parameters by saying A is equals to 5.6 meters, then B is equals to 4.8 meters, and we know that angle C, that is 20.4. Let's put it in the diagram. So we have angle C to be equals to 20.4 degrees. So to find C, side C, we need to make use of cosine rule. That will be C squared equals to A squared add B squared, subtract 2 into A into B, then cos C. So if you key in the values, we have C squared to be equals to 5.6 squared add 4.8 squared, subtract 2 into 5.6 into 4.8, then cos 20.4 degrees, 20.4 degrees. Okay, so you can key in this directly into your calculator. and you will get your answer to be c squared to be equals to 4.011. If you take square root of both sides, then the value of c will be equals to 2.00 to three significant figures. So this will be 2.00. That's the value of the length AB. Then angle XBA is equals to 64 degrees. That is XBA. Let's see. This is XBA. So this angle here is giving us 64 degrees. Okay, so what are we asked to do? Calculate AX. So we want to find AX. So that is a right angled triangle. So let me sketch it out. We're going to have something like this. This will be up here and this will be here. So you can have this place to be. Let's see the diagram again. So we have X, B, and A. So this will be X, this will be B, and this will be A. So this will be a right angle as shown in the diagram, and this place is 64 degrees. So we want to find AX, and mind you, don't forget that we've already found the length AB to be 2.00, which is 2 meters. So to get AX now, we can make use of SOHCAHTOA. In this case, it will be tan 64 degrees to be equals to AX, the required side, out of 2. Okay, so if you cross multiply, you have AX to be equals to 2 times tan 64 degrees. So this will be equals to 4.1. So you can easily get the value of this by using your calculator straight away. That will be equals to 4.10. So you don't need to waste your time computing this because you have limited time. So the value of AX is 4.10. Okay, so always leave your answer in 3 significant figures and your angle in 1 decimal place. Okay, so Roman figure 3, AY is equals to 2.9, whereas AY, okay, from here, AY is equals to 2.9 from the diagram is 2.9, and we have to calculate the area of triangle YAC. So let me sketch the diagram here. We have something like this. Okay, so you have A to be here. This is a right angle. Then Y is here. Okay, then we have 4.8 here. Then this will be 2.9. That is AY. Okay, so C is here. So this is a right angle triangle. So the area of a right angle triangle is base times height out of 2. If you key in the values, you have 4.8, that's the base, times the height, 2.9, then everything out of 2. And if you key in this to your calculator, the area will be 6.96 meter squared. That will be the area of triangle YAC. So let's go to the next question. That will be part B. In triangle PQR, M is the midpoint of PQ. RM is equals to 8 centimeters. Angle PRM is equals to 30 degrees. And angle RMQ is equals to 75 degrees. Calculate PQ. Okay, so from what you have here, you can easily make use of sine rule. Okay, so want to find PQ. This is the whole of this. Okay, that's the base of the whole diagram here. And to do that, we can easily find this place first. If this place is 75, so you can calculate this angle here by subtracting 75 degrees from 180 degrees, because these two angles are angles on a straight line. So we're going to have 105 degrees here. You need to do this. That is, you can say that angle PMR, okay, is equals to 180 degrees subtract 75 degrees, and that will give you 105 degrees as shown here. Then we can get this angle MPQ. So because these three angles add up to 180 degrees, sum of angles in the triangle, so you can say angle MPR is equals to 180 degrees subtract 105 subtract 30 degrees. So if you do that, you will get 45 degrees here. Now, it is easy for you to find PM now. So the diagram I have here, I can sketch it out. Let's scroll down a little bit. So I have something like this here. Then you have this and you have this. So this will be point P, this will be point M, and this will be point, let's scroll up, I think that should be point R. Yes, this will be point R. So I have this angle to be 45 degrees, this place to be 105 degrees, and this place to be 30 degrees. So this place is 8 meters. So I can find PM, okay? So I can find PM. So don't forget that M is the midpoint of PQ. That means PM and then QM are equal. So once I find PM, then I'll just multiply it by 2. That will give me PQ. Okay? So now what I will do is this. Using sine rule, I want to find PM. So it will be this 8 centimeters, okay, using sine rule, 8 centimeters over sine 45, that is this side over the sine of the opposite angle, there must be equals to PM, this side, PM, over sine of the opposite angle, it will be sine 30 degrees. Then if you cross multiply, we have PM times sine 45 degrees to be equals to 8 times sine 30 degrees. So you have PM times sine 45 degrees. You can divide both sides by sine 45 degrees, sine 45 degrees, sine 45 degrees. So this will cancel out this. We have PM to be equals to, you can input this directly into your calculator. So you have 8 by sine 30 is 0.5. I have out of 0.7071, that is sine 45. And if you do this, you get PM to be, let's scroll up a little bit. We have let's scroll down rather. We have PM to be equals to 5.6569. That's the value of PM. So we can now get PQ to be equals to 2 into PM. So that will be 2 into 5.6569, and that will give us 11.3 centimeters. So the length of PQ is 11.3 centimeters. So let's go to the next question. This is a curve cumulative frequency diagram. We have the speed, we have the cumulative frequency, and on the grid we are asked to draw the cumulative frequency diagram. So I'm going to insert the point and sketch the curve. So I have plotted the points and traced them. So this is what you have. That is the curve, the the cumulative frequency diagram. That is what you are asked to do. Now let's go to the next question. So use your cumulative frequency diagram to find an estimate of the median. So to get the estimate of the median, so we have to find the median class by using n out of 2 to get the median class, and that will be 200 out of 2. That will be the 100th value. So we need to go to the cumulative frequency diagram and mark out 100th value. So 100 will be this. So we trace it to the curve and get the corresponding value. Now I have traced the 100th value to the curve and traced it to the corresponding speed, and I have 88.5, a little bit more than 88. So I will go to here and write 88.5 kilometers per hour there. So the next one is to find the interquartile range. The interquartile range I is equals to Q3, that is the upper quartile, subtract Q1, that is the lower quartile. Okay, so the Q1 will be 1n out of 4. That's how you get the lower quartile class. Okay, and in this case it will be 200 out of 4, and if you do this it will be the 50th. And for the upper quartile Q3, it will be 3n out of 4. Okay, so that will be 3 times 200 out of 4, and that will be the 150th value. So I'll go to the cumulative frequency diagram and locate the 50th and the 150th values. The 50th term has been traced, and is the green one here is almost 80, that is 79.9. Okay, and I've also traced the 150th value. Okay, so that's the blue one, and that is 94. Okay. You need to be very careful when you are drawing the curve. You have to make use of the French curve for you to have accurate results. So I can go back to the next page. So I can say the interquartile range will therefore be, the value of the Q3 is 94. Okay, subtract 79.9, which is almost 80, and the answer will be 14.1. Okay, so this has to do with the curve. Okay, so when you are drawing your curve, try to make use of the French curve for you to have accurate results. Okay, so let's go to the next question. So the number of cars with a speed greater than 110 kilometers per hour, so it will be 100 and greater than 110. Okay, so we need to go to this diagram again. So 110 is greater than 110. We need to mark this up and get the corresponding value. I have traced the 110 kilometers per hour up. Okay, so up to the curve, and the corresponding cumulative frequency is here. So that means we need to do 200 minus 190. So that's what we need to do. So if we scroll down, the number of cars with a speed greater than 110 kilometers per hour, it will be 200. It will be 200 subtract 190, and that will be 10. Okay, so that will be 10. So if you look at the diagram here, it will be 200 minus 190, and it will be 10. That will be greater than that. So that is our answer. So let's go to the next question. So calculate an estimate for the mean of the trucks. So here we need to get the class mark by getting the average of each of these. Okay, so we need to find the average of each of these masses. So let's find the class mark. That will be x. So if you add 2000 to 2600 and you divide by 2, you will get 2300. Then for the second column, you get 3050. For the third column, you have 4250. Then the last one, you have 5350. And the frequencies remain the same. You have 12, 15, 16, and 7. Okay, so of course the total frequency will be 50. Okay, then we need to find the product of f and x. So if you multiply 2300 by 12, you have 27600. So this will give you 45750, and this will give you 68000, and this will give you 37450. So if you get the total of this one, it will be 178800. So summation fx is equals to 178000, and summation f is equals to 50. Then we can now calculate the mean. The estimated mean will now be 178000 out of 50, and the mean will be 3576. That's 3,576 kilograms. So that will be the estimated mean. So in a histogram showing this information, the height of the first block is 6 centimeters. Calculate the height of the remaining 3 blocks. So to do this, you need to understand that the frequency density, when you have something like this, okay, so the frequency density is always the height, okay, is the same thing as the height of the bars there. So we're going to use a relationship. So we will say, since we know that the frequency density FD is equals to height of each of the bars, okay? So we are going to use this relationship, and that will be FD1 over FD2 equals to H1 over H2. So that is what we are going to use, okay? So this is the relationship we are going to use. So to calculate the frequency density, already you know that frequency density is equals to the frequency over the class interval, the class size, okay? So let's calculate the FD1. The FD1 will be equals to, that's the frequency density of the first class interval. That will be 12 over 600, okay, because the frequency is 12 and the class size is 600, that is 2600 minus 2000, so the class size will be 600. So that means FD1 will be equals to 0.02, so FD1 will be equals to 0.02, and we've been given the height of this class to be equals to 6 centimeters, okay? So then we can now find FD2, the FD2, the frequency density of the second one. It will be the frequency, which is 15, out of the class size will be 3,500 minus 2,600. That will be 900. So the frequency density of the second class interval will be 15 out of 900, and this will give us 0.0167. Okay, so from this now we can get the H2. So it will now be FD1 over FD2 is equals to H1 over H2. By the time you key in the values, you have 0.02 out of 0.0167 is equals to 6 out of H2. So this will give you the height, and if you cross multiply, so you finally have H2 to be equals to 6 times 0.0167 out of 0.02. So H2 will be equals to 5 centimeters. So that means the height of this will be 5 centimeters. So you follow the same process. You find the third frequency density, okay, using F over the class size, and the FD3 will be equals to 0.011. Then you can now use the same formula, that is this formula here. Okay, you can now use this one now. Okay, so it will now be FD1 over FD3 equals to H1 over H3. So if you do that, you get the value of H3 to be equals to 3.2 centimeters. So you can also use this formula again to calculate FD4. So the FD4 will be equals to 7 over 700. So FD4 will be equals to 7 out of 700, and that will be 0.01. And you can still use this formula again, that is FD1 over FD4 equals to H1 over H4. Follow the same steps, and you will get the H4 to be equals to 3 centimeters. So that is how you can get the height of the remaining blocks. So let's go to the next question. So this is question 7. The diagram shows the graph of a function. Put a ring around the word which correctly identifies the type of function. Okay, you can see that it cut the x-axis here, cut it here, and it cut it here. So it has 3 solutions. So that will be a cubic function. So let's go to the B Roman figure 1. On the diagram, sketch the graph of y equals to 1 out of 2x, where x is not equals to 0. So this equation is called a reciprocal equation. So it's of the general form y is equals to a out of x, and the graph is called a hyperbola. Okay, so what we need to do is to write this 1 over 2x in this form. So it will be y is equals to 1 over 2 divided by x. So it will be y equals to 0.5 over x. So now it's of this standard form now. Okay, so now we can say a is equals to 0.5. So if a is less than 0, so the hyperbola will be here and here. But if a is greater than 0, then it will be here and here. So since our a is greater than 0, it is 0.5. That means the two curves of the hyperbola will be here and here respectively. Okay, so you need to take the following steps, okay, so which we have done. So we have taken one step to know the location of the two curves. So the next thing is to check if there is intercept. Of course, for you to have intersect, x must be equals to 0 and y must be equals to 0. But in this case, x can never be 0 and y can never be 0. That means there is no intercept on x-axis and there is no intercept on y-axis. So the next thing, which is the last one, is to check if there is asymptotes. And asymptotes is a line that approaches a curve but we never touch it. Okay, so in this case, the x-axis will be an asymptote, the y-axis will also be an asymptote. So this is how we sketch the two curves of the hyperbola. So the first one will be this. You sketch it, it will never touch the x and the y-axis respectively. Then the second one will also be somewhere around there. It will never touch the x and y-axis respectively. So this is how you sketch the hyperbola. So the next question is Roman figure 2. Solve the equation 1 out of 2x to be equals to 2x. If you cross multiply, you have 4x squared to be equals to 1. Divide both sides by 4, you have x squared to be equals to 1 out of 4. If you take square root of both sides, so that means x will be equals to plus or minus 1 out of 2. So that means x will be equals to plus a half and minus a half. So that will be your solution. Then the next question will be see Roman figure 1. On the diagram, sketch the graph of y equals to sine x for 0 degree less than or equals to x, and x is less than or equals to 360 degrees. So it passes through 0 and it does not go beyond 1 and -1. So it will come, we have something like this. It will come like this, like this. Then you have something like this as well. Okay, so that is what you have. So that's how to sketch. So you need to be careful. It must not go beyond 1 and -1, and it enters 180 and 360 respectively, starting from 0. So you can clean this and leave it like this. So let's scroll down and solve the remaining part of the question. Solve the equation 3x plus 1 equals to 0 for 0 degree less than or equals to x and x less than or equals to 360 degrees. So you have 3 sine x plus 1 to be equals to 0. So that will be equals to 3 sine x to be equals to -1. If you divide both sides by 3, you have sine x to be equals to -1 out of 3. So that will be equals to sine x to be equals to minus 0.3333. Then you take sine inverse of both sides. So x will be equals to sine inverse of -0.3333, and the value of x will be -19.5. Okay, of course, this is not part of our solution as it is out of the given boundary. Now let's illustrate -19.5 on the x and y axis like this. Okay, so since it is -19.5, okay, so the direction will be opposite direction like this. Instead of it going anti-clockwise, it will be clockwise direction because of the negative sign. So this will be 19.5 degrees. Okay, so we don't need to put the negative sign here because the negative sign tells you the direction. Okay, so I'll also put the same angle here because these two angles are equal, 19.5. Okay, so the first value of x will be from 0 up to this. That will be the first value, and that will be 180 degrees at 19.5 degrees, and that will give me the first value, which should be 199.5 5. Okay, so that will be the first one, and the second one will be from here up to this point here. Okay, so that will be 360 degrees subtract 19.5 degrees, and that will give me 340.5 degrees. So these are the two values of x that fall into the given boundary. So let's go to the next question. That will be question 8. A shop sells shirts for X dollars and jackets for X plus $27. The shop sells 4 shirts and 3 jackets for a total of $194.75. Write down and solve an equation to find the cost of one shirt. Okay, so we can say let the shirt be equals to x. Okay, one shirt to be equals to x. Okay, one jacket, okay, to be equals to x plus 27. Okay, so it will be x plus 27. Okay, so the shop sells 4 shirts and 3 jackets for a total of this. That means we're going to have 4x, that is 4 shirts, plus 3 jackets, 3 into x plus 27, and this should add up to 194.75. So we have 4x. So let's expand this bracket, add 3x, then add 81 to be equals to 194.75. So this and this add up to 7x. Then we need to bring this to the other side, and you have 194.75 subtract 81, and that will give you 7x to be equals to 113.75. If you divide both sides by 7, then the value of x will be equals to 16.25. That means the cost of one shirt will be $16.25. Okay, so let's scroll down for the B part. Solve the simultaneous equations. You must show all your working. So let's call this equation 1 and this to be equation 2. Okay, so we can divide this into 2 parts. Okay, so from equation 2, let's make y the subject of the formula. So that will be y to be equals to negative 8 subtract 5x. You can call this equation 3. Then let's put equation 3 into equation 1. So that means you have s squared plus 4. So this is the value of my y, negative 8 subtract 5x. So that will be plus 4 into negative 8 negative 5x and equals to 37. Let's expand the bracket. You have x squared subtract 32, then subtract 20x to be equals to 37. So if you rearrange, we're going to have x squared minus 20x minus 32, then minus 37 to be equals to 0. So this will give you x squared minus 20x and minus 69 equals to 0. So this is a quadratic equation. So the value of a equals to 1, b is equals to negative 20, c is equals to negative 69. So using the quadratic formula, x equals to minus b plus or minus square root of b squared minus 4ac, everything over 2a. So if you key in the values, you have the value of x to be equals to negative 20 plus or minus square root of, so plus or minus square root of minus 20 squared, then minus 4 into 1 into negative 69, everything over 2. So if you do this, you will get the values of x to be equals to negative 3, or the value of x to be equals to 23. So you need to key in these values into equation 3, that is y is equals to negative 8 subtract 5x. So when x is equals to negative 3, so you have y to be equals to negative 8 minus 5 into negative 3. So if you solve this, you get y to be equals to negative 8 and 15, and y will be equals to 7. So that is when x equals to, let's scroll down a little bit, when x is equals to negative 3, y is equals to 7. Similarly, you need to do y is equals to negative 8 subtract 5 into 23. So that is when x equals to 23. And this will give you y to be equals to negative 8, negative 115. And y will be equals to negative 1, 2, 3. So that means when x equals to 23, the corresponding value of y is negative 1, 2, 3. So that is the solution to that question. So let's go to the next question. So that is part C. A solid cylinder has radius x and height 6x. A sphere of radius r has the same surface area as the total surface area of the cylinder. Show that r squared equals to 7 out of 2 s squared. The surface area A of a sphere with radius r is given as this. Okay, so we are being given the surface area of a sphere, which is this. So even though you're not given, you should know this offhand. And we need to get the total surface area of a solid cylinder. So for a solid cylinder, so this is what you have. Okay, you have the circular top, you have the circular base, and you have the curved surface area. So the area of the circular top is pi r squared, area of a circle, and the circular base is also pi r squared, and the curved surface area of a cylinder is given as 2 pi rh. So the total surface area of this solid cylinder will be 2 pi rh plus 2 pi r squared. So, but you know that for the cylinder, the radius of this cylinder is equals to x, and then the height is equals to 6x. The surface area of the sphere is equal to the total surface area of the solid cylinder. That means I can say the surface area of the sphere, that is 4 pi r squared, is equal to the total surface area of the solid cylinder, which is 2 pi rh, that is the curved surface area of the solid cylinder, plus the sum of the areas of the circular top and the circular base, that will be 2 pi r squared. But we are told that the radius of the cylinder is x and the height is 6x. So I need to change this and this and this. So I have 4 pi r squared to be equals to 2 pi into r is x into h is 6x. Okay, then plus 2 into pi, or 2 pi into r, which is x, then squared. So if you notice very well, if you observe this, you will see that 2 pi is common, so I can factor out 2 pi. So I can say let's divide through by 2 pi, or you can factor it out, anyone. So I'll divide through by 2 pi, since 2 pi is common. 2 pi, 2 pi, 2 pi. Okay, so this will cancel this will cancel this, and pi will cancel pi. 2 here 1, 2 here 2. So that means I have 2 r squared equals to 6x squared plus x squared left here. I have 2r squared to be equals to 7s squared. Then I can make r the subject of the formula by dividing both sides by 2. I have r squared equals to 7 out of 2, then s squared. So we have shown that r squared is equals to 7 out of 2 s squared as required here. So the next thing is to go to the next question, and that is question 9a. The diagram shows a shape made from a square ABCD and 2 equal sectors of a circle. The square has side 11 centimeters. MAB and DCN are straight lines. So if they are straight lines, so that means you have 90 degrees here, and you also have 90 degrees here. So calculate the area of the shape. Okay, so we know that the square has side 11. That means here will be 11 centimeters, 11 centimeters, 11 centimeters, 11 centimeters. Okay, and we know that AD and AM are equal because they are radii. So I can put 11 here as well. So the same thing, BC and CN are also equal because they are both radii. So I can put 11 here, and already I have 90 degrees here. I have 90 degrees here. So to calculate the area of the shape, the O shape, I need to calculate area of the square, then calculate area of one of the sectors and multiply it by 2 to get the area of the two sectors because they are similar, they are equal. So, and I'll add everything together. That will be my final solution. So let's calculate the area of the square. The area of the square is given as length times length, and that will be 11 by 11, and that will be 121 centimeter squared. That will be 121 centimeter squared. Okay, so we need to calculate the area of the two sectors, but they are similar. Once we calculate area of a sector, then we multiply it by 2. That will be the area of the two sectors. So the area of a sector is given by theta out of 360 times pi r squared. So we know that theta is 90 degrees. So it will be equals to 90 degrees out of 360 degrees times pi is 3.14 by the radius is 11 centimeters. By the time you square it, that will be 121 centimeter squared. That will be the radius squared. Now, if you key in these parameters into your calculator, the area of a sector will be equals to 94.99 centimeters squared. So that means the area of the two sectors, since they are similar, will be equals to 2 into 94.99, and that will give us 189.98 centimeters squared. So the area of the O shape, that's the area of the figure, will now be the area of the two sectors, that is 189.98 centimeters squared. Add the area of the square, which is 121 centimeter squared, and that will be approximately 311 centimeters squared to 3 significant figures. Then the Roman figure 2 is to calculate the perimeter of the shape. Okay, you can see we need to add all the sides together. We only have 2 sides left, which are unknown, the curve arc MD and arc BN. So that is length of an arc. So we just calculate the length of an arc and we add everything together. So the first thing we need to do is to get the length of an arc. The length of an arc, denoted L, is equals to theta out of 360 times 2 pi r, and the theta remains 90 degrees out of 360 degrees, multiplied by 2 by 3.14 by 11 centimeters. So if you key in this into your calculator, then the length of the arc should be 17.3 centimeters. So if you go back to the diagram, so that means this arc MD is 17.3 centimeters and the arc BN is also 17.37. So the perimeter of the shape will be the addition of the whole sides, that is this, add this, add this, add this, add this, and add this. So if you do that, we'll have the perimeter to be equal to 11, add 11, add 17.37, add 11, then add 11, then add 17.37. So the perimeter will be 2 into 1, 2, 3, 4, 2 into, that will be 4 into 11, because we have 4 of it there. Then add 2 into 17.37. So if you do this, you get the perimeter to be equal to 44, add 34.6, and the final perimeter is equal to 78.6. That's what you get. You get 78.6. So question 9b. The diagram shows a cube A, B, C, D, E, F, G, H of edge 7 centimeters. Calculate the angle between AG and the base of the cube. So it is obvious that this will be 7 centimeters, 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 7 centimeters. So we need to draw a line from A to G. So this is what you have left. So you can sketch it out. You have something like this. Then this will be A, this will be G. Then we can complete the right angled triangle. So this will be point C. Okay, so I want to find the angle here. Okay, and already we know that GC from the diagram is 7 centimeters. So we need to find AC. So if we can find AC, and so we need to find AC by using triangle ABC. So that will be the hypotenuse of the right angle triangle ABC. So that will be the square root of 7 squared plus 7 squared. Okay, so that is what AC will be. And we can now find the angle A now using SOHCAHTOA. So that is opposite over adjacent. So here we can say tan, let the angle be theta. We can say tan theta to be equals to 7 out of square root of 7 squared plus 7 squared. So tan theta will be equals to 7 out of square root of 49 add 49, and tan theta will be equals to 7 over square root of 98. So if you simplify that, that will give you, so from here we have tan theta to be equals to 0.7071. So if you divide 7 by root 98, okay, you have that. And finally, theta will be tan inverse, okay, of 0.7071. Then theta will be equals to 35.3 degrees. That will be the value of theta. So let's go to the next question. That will be question 10. The table shows some values for y equals to 2 to the power of x, subtract 3. So complete the table. So you can easily press the whole of this, you can easily input the whole of this equation into your calculator and generate the values for y respectively. Otherwise, you have to substitute the values of x one after the other and you get it. That is, when x equals to -1, when x equals to 1, and solve. But it's easy when you key in this into your calculator. So when x equals to -1, y is -2.5. You key it into your calculator. When x equals to 0, y is equals to -2. And finally, when x equals to 1, y is equals to -1. So the B part of it is to draw the graph of y equals to 2 to the power of x subtract 3 for this given range. So I'm going to do that and show you the results. So I have plotted the values of x against the values of y, and this is the curve we have on the grid. So part C, we are to use the graph to solve the equation 2 to the power of x minus 3 equals to 2. So if you observe it very well, you'll see that the left hand side is equals to y. So that means y is equals to 2. So that means the solution is where y is equals to 2 touches this curve. So we need to draw a line where y is equals to 2, and it will be here. So let's draw the straight line. So the line y equals to 2 touches the curve at this point, and if you trace it down, it will be 2.3. So that's the value here. It is 2.3 here. So we can go back to the question and so the line y equals to 2 touches the curve here, and if you trace it down, it is 2.3. So that means we can say the solution is equals to 2.3. Then by drawing a suitable straight line, solve the equation 2 to the power of x, subtract x minus 1.5 equals to 0. So the first thing we need to do is to write 2x is to write 2 to the power of x minus 1.5 to be equals to 0 in form of 2 to the power of x such that there is -3 there. Okay, so how do we do that? So we need to add minus 1.5 to both sides. So that means we're going to have 2 to the power of x minus 1.5, then add minus 1.5 equals to 0, then add minus 1.5. So if you do this and this will add up to minus 3. Okay, so we have 2 to the power of x minus 3 to be equals to minus 1.5. So this is 1.5 here, minus 1.5. Okay, so we can now rearrange to have 2 to the power of x minus 3, then equals to, let's transfer negative x to the right hand side, that will be positive x, then minus 1.5. So the left hand side is now y, that is letter y is equals to x minus 1.5. Okay, so that means we need to draw this straight line. So the intercept on y-axis is at minus 1.5, then the gradient is 1 out of 1. That means you rise 1 and you move forward 1. Okay, so let's do that. The intercept on y-axis is minus 1.5. That means there is a point here, that's minus 1.5. Okay, so if you go take a step once, it will be here. Now this is what we need to plot. We need to plot y equals to x minus 1.5, but there is a shortcut to this. If you compare this with the general equation of a straight line, you have y to be equals to mx plus c. So from here, it is clear that the intercept on y-axis intercept on y-axis is c is equals to minus 1.5, and then the gradient m is equals to 1 out of 1. That is, this is rise over run. Okay, that means you rise in equal number of time you run. Okay, so if you take half a step, if you rise half a step, you run half a step. If you run full step, then if you rise full step, then you run full step. So let me show you. The intercept on the y-axis is minus 1.5. So this will be a point minus 1.5. So from this intercept on the y-axis, then I want to rise, taking half a step here. That is here now. I'm at 1. Then let me move forward with half a full box. Okay, that's half a step. So another one will be here. Okay, from here, let's take half a box again here. Then let's run half a box. It will be here. So you have another point here. From here, let's rise half a box. It will be here. Then let's run half a box. It will be here. So you can have as many as possible points. So let's rise half a step. It will be here. Then run half a step. It will be here. So once you have 3 points, okay, so the 3 points are enough for you to draw the straight line, and you can still come down a little bit from here, from the intercept on y-axis. If you fall half a step, then you move backward half a step. So that means from here, the other one will be here. Okay, if you want to have more. So if you fall half a step, then you run, you move forward half. If you fall half a step, then you run backward, you move backward half a step. So another one will be here. So that means we need to join these together. That will be the solution to this. So I have drawn the straight line y equals to x minus 1.5, and it touches the curve at 2 points here. It touches the curve at 2 points here. It touches the curve at 2 points here and here. So we need to trace it to the x-axis. Of course, if you trace this one up here, it is -1, and if you trace the other one, it is about 1.7. Now I have traced the 2 points to the x-axis. So the first one is -1, and the second one is here. It is 1.7. So I can now write the solution here as s equals to -1 and s equals to 1.7. So let's go to the next question. M has coordinate 4, 1. That implies that x1 is equals to 4, then y1 is equals to 1. That is for the first point. For the second point, we have x2 to be equals to -2 and y2 to be equals to -7. Okay, so find the length of mn. So to find the length of mn, we make use of the formula mn to be equals to square root of x2 minus x1 squared add y2 minus y1 squared, and this will be -2 minus 4 all squared add -7 minus 1 all squared. Then you take the square root. So if you do this, you have square root of minus 6 squared, then add minus 8 squared, and finally your answer will be square root of 36 add 64, and you have 10 units. Okay, as this will give us square root of 100, and the answer is 10 units. So we have to find the gradient of mn. Okay, so the gradient will be equals to y2 minus y1 over x2 minus x1. If you key in the values, you have minus 7 minus 1 out of minus 2 minus 4, and this will give us minus 8 minus 6, and that will be 4 out of 3. That is the gradient. And the C part of it, find the equation of the perpendicular bisector of mn. So if you have line mn to be this mn, then the perpendicular bisector will be this. It will divide this mn into 2 equal halves, and then you can call that point, let's say point Q, and the coordinates, it will be x comma y. So that means the equation of the perpendicular bisector of mn passes through the coordinates x and y. Then we need to find, we know that if they are perpendicular, then their gradient m1 for the gradient of mn, and then m2 for the gradient of the perpendicular bisector, the product must be equals to -1. So we already found the gradient of mn, which is m1, as 4 out of 3 times m2 equals to -1. So if you multiply both sides by 3 out of 4, that is 3 out of 4 times this, then times 3 out of 4, you'll be left with m2 here, and it will be minus 3 out of 4. So that means m2, which is the gradient of the perpendicular bisector, is -3 out of 4. Okay, then we need to find the point where the perpendicular bisector passes through by finding the midpoint of line mn. So the x coordinate will be x1 add x2 out of 2. So we already denoted the value of x1 to be 4, then x2 to be -2 out of 2. This will be 2 out of 2. That will be 1. So that means x is equals to 1. Then the y will be y1 add y2 out of 2. So that will be 1 add -7 out of 2, and that will be -6 out of 2, and that will be -3. So that means y is equals to -3. So it implies that the equation of the equation of the perpendicular bisector of mn passes through s equals to 1 and y equals to -3, and the gradient is -3 out of 4. So using y minus y1 equals to n into x minus x1. So let's key in the values. You have y. So our y1, that is where it passes through now. So it will be, this will be y1 now, -3. It will be our y1, it passes through this, okay? So that will be -3, then equals to the gradient, -3 over 4 into x minus x1. So this is where it passes through. Okay, I think in order to avoid confusion, it is better we change this y1, because we already have y1 and y2 up here. So it's better we change this to x3 and y3. So this will be x3 to be equals to 1, then y3 to be equals to this. And from the equation here, you have y minus y3 and x minus x3, in order to avoid confusion. Okay, so you have y minus y3 into the gradient into x minus x3, which is 1. So this will give me y add 3 then to be equals to, let's expand the bracket, minus 3 out of 4 into x, then plus 3 out of 4. So we need to simplify this further. That will be y to be equals to minus 3 out of 4 into x plus 3 into 4. Then this will be minus 3. So we need to do these two. So if you simplify these two, you have y to be equals to minus 3 out of 4 x. Then you have minus 9 out of 4. So if you like, you can leave your answer like this. This will be in form of y is equals to mx plus c. And if you like, you can proceed by multiplying through by 4. So that will give you 4y to be equals to 4 will cancel 4. That will give you 4 by y equals to 4 by minus 3 over 4x minus 4 by 9 over 4. So this 4 will cancel this 4. This 4 will cancel this 4. Then you are left with 4y to be equals to minus 3x, then minus 9. Then you can put everything by the left hand side. That will be 4y add 3x add 9 equals to 0. So you can either leave your answer like this or like this. So I will go by this, y equals to minus 3 over 4x, then minus 9 over 4. So that will be the solution to that question. And let's go to the last question, that is 12. The equation of a curve is y equals to x to the power of 4 minus 8x squared plus 5. Find the derivative, that is the y dx of this given curve. So the y dx, it will be equals to 4 times x, that is 4x, then 4 minus 1, that is 3, then 2 times negative 8x, that will be negative 16x, then 2 minus 1, subtract 1 from the power, you have this, and of course plus 0. So that means the y dx is equals to 4x cubed minus 16x. So that is the derivative. Then let's go to the part B. Find the coordinates of the 3 turning points. You must show all your working. So we know that at the turning point, the y dx is equals to 0. That means we can simply say 4x to the power of 3 minus 16x is equals to 0, because this is the y, the x, the gradient. So now 4x is common, then you can factor out 4x. You have x squared left here, then minus 4 left here equals to 0. It implies that 4x is equals to 0, or x squared minus 4 equals to 0. So from this, it is obvious that x equals to 0, and from this one you can say x squared equals to 4. If you take square root of both sides, then x will be equals to plus or minus 2. That means the values of x are 0, 2, and negative 2. So when x is equals to 0, let's find the corresponding value of y by substituting into this y is equals to x to the power of 4 minus 8x to the power of 2, then plus 5. Okay, so let's do the first one. So when x is equals to 0, then that means we have y to be equals to 0 minus 0 plus 5. Then it implies that y equals to 5. So I can put the first coordinate here. When x equals to 0, y is equals to 5. That is the coordinate of one turning point. Then when x equals to 2, so that means we have y to be equals to 2 to the power of 4 minus 8 into 2 to the power of 2, then add 5. So if you do this, this will give us y to be equals to 16, subtract 2 times 2, that is 4, 4 times 8 is 32, then add 5. So if you do this, it will give us minus 11. So that means when x is equals to 2, y is equals to negative 11. So the same thing, when you substitute x equals to negative 2, okay, you also get the value of y to be negative 11. So negative 2 against negative 11. So these are the coordinates of the 3 turning points. Okay, now let's go to the C part of the question, and that will be the end of this solution. Determine which of these turning points is a maximum. Justify your answer. Okay, so for you to know the behavior of each of the turning points, it is very important for you to find the second derivative. It is easier. So already we know that the first derivative, that is the y, the x, is equals to 4x cubed, then minus 16x. To find the second derivative, that is the square y out of the x squared, will be equals to, so 3 times 4x, that will be 12x, then subtract 1 from the 3, then we are left with 2. Then we have 1 here, 1 times 16, you have 1 times 16x, you have 16x. Okay, so 1 minus 1, you have 0. Okay, that means you have 0 here. So this is the same thing as the square y over the x squared equals to 12x squared minus 16. So I just have to show you the derivation. Okay, that's x equals to s to the power of 0 has to be 1. Okay, I will have written this directly. Now, so this is the second derivative. So we need to plug in the values of each of the turning points, that is the x values, the x coordinates of each of the turning points. That is, we have to plug in the x. We have to plug in the x coordinate of each of the turning points to see the behavior before and after the turning point. Let's start with 0. Okay, so if s equals to 0, that means the square y, the x squared, will be equals to 12 into 0 squared minus 16, and that will be negative 16. That means it was decreasing. So that means it is decreasing rather. So the square y, the x squared, is what? Is less than 0 at the turning point with the coordinates 0, 5. So it means that this is decreasing, and it means that that's less than 0. So if the second derivative is less than 0, that means it is decreasing after the turning point, and that implies that it was increasing before the turning point. So we have maximum point here. So this will be maximum point. So at 0, 5, you have maximum point. Okay, so this one is the maximum point. So you don't need to check for the remaining ones, okay? Because look at this, we are asked to determine which one of these turning points is a maximum. Okay, since the first one has given you maximum, so you don't need to waste your time to do others. Okay, so that means it is 0, 5 that is maximum. But for revision sake, so we can do the same thing for the other points. That is, if the square y, the s squared, is equals to 12s squared minus 16. So let's key in the value of s equals to 2 to see the behavior of that turning point before and after. So that means we're going to have 12 into 2 squared minus 16. So this will give you 12 into 2 squared is 4, then subtract 16. So this will give you 48, then subtract 16. Of course, we don't really need to get the answer here. We know that at s equals to 2, y equals to minus 5, that turning point. So the behavior of the square y, the second derivative, is positive, greater than 0. So if it is positive, so that means it is increasing after the turning point, and that implies that it was decreasing before the decimal point. So you have minimum point. Okay, if you do for x equals to minus 2, you see that you also have minimum point as well. So the maximum point is at s equals to 0 and y equals to 5, this turning point. Thank you. This will be the end of the solution until we meet again for solution to the component 4.1. Enjoy yourself and stay cool.